Let's jump right into this explainer. We're talking about May 13th. On the surface, it might seem like just another day on the calendar, right? But it is secretly one of the most important markers in human history. It's an absolutely golden day in math.
Think about your phone's GPS, modern video games, and the entire internet. What do they all actually have in common? Well, the answer isn't a thing, it's a date. Because on this one precise day, spread across completely different centuries and vastly different countries, brilliant minds literally changed the fundamental rules of the world we live in today. Let's meet them. If we look at the timeline, we have 1750, a spark of genius in Italy. 1931, a breakthrough in Hungary. 1984, a legacy in the USA. And 2005, a modern revolution completed. We're going to trace this wild thread through time, all anchored to May 13th.
So we'll start our detective story with a modern wonder. Have you ever wondered why delivery apps and navigation systems just instantly know the perfect path? Like, why does Google Maps always find the fastest route even with hundreds of intersecting roads, weird speed limits, and traffic jams? I mean, that's literally millions of possible combinations it has to process in a fraction of a second.
Well, the answer goes back to May 13th, 2005, and a guy named George Dantzig. He invented this incredible thing called the Simplex Method. Simply put, it's a mathematical way to find the absolute best possible outcome in wildly complex situations. Imagine, navigating the outside edges of this massive, complex 3D shape to find the highest point. That's kind of what his algorithm does with data. Instead of getting bogged down checking every single point inside the shape, he figured out how to just slide along the edges of possibilities. We're literally using his mathematical programming every single time our phone calculates the quickest way home. It's a real game changer.
Even Dantzig himself once said, "The tremendous power of the Simplex Method is a constant surprise to me." And yeah, no wonder. Every time you save time on a journey today, whether you're commuting or waiting for a package, you are secretly relying on his math.
Okay, 2005 is Dantzig's optimization legacy, but let's slingshot backward 21 years to 1984, still on May 13th, but now we're at the dawn of digital randomness. Have you ever thought about how our digital worlds create perfectly unpredictable events? Like, how does a sudden rainstorm happen naturally in a video game? Or how does AI confidently predict future trends using statistics without knowing exactly what's going to happen?
The answer for this one takes us back to May 13th, 1984, and a Polish-American genius, Stan Ulam.
So, picture this. He's recovering from an illness, playing endless games of solitaire, and he comes up with what we now call the Monte Carlo Method. It's a technique that uses the sheer power of randomness and statistical sampling to solve incredibly complex problems. Instead of painstakingly calculating every single possibility to find a perfect answer, the Monte Carlo Method essentially just throws thousands of random darts at the problem to find the most likely highly accurate answer. It's amazing. Today, our massive computer simulations, weather models, and game engines rely entirely on his brilliant use of chance.
Ulam later wrote, "My first thoughts on this method were suggested by a simple question while playing solitaires." Think about that. From a simple, solitary card game played in bed, we got the secret engine of chance driving modern computing. Without his work, modern simulations literally wouldn't exist.
All right, we've covered Ulam's Monte Carlo method in 1944. Now let's jump way back, 2 whole centuries, to the elegance of Italy in 1750, still happening on this exact same golden date.
Think about digital design software for a second. How do designers achieve absolute geometric perfection without a physical ruler? How do graphic engines draw these flawless objects and perfectly smooth, scalable vectors without ever needing a straight edge? Well, the answer goes back to May 13th, 1750, and an Italian mathematician and geometer, Lorenzo Mascheroni.
He invented compass geometry. Basically, he proved mathematically that every single geometric shape could be constructed using only a compass. Imagine trying to draw a perfect square or some complex polygon, but someone takes away your ruler. It sounds impossible, right? But he showed us that taking away tools, specifically the straight edge, can actually force absolute perfection, relying purely on curves and intersections. This mathematical elegance perfectly mirrors the constraints and precision tools we use in vector graphics today.
Mascheroni famously noted, "Ruler and compass could perhaps be separated, as water can into 2 gases. It's such a beautiful truth. Setting strict limits and stripping away our most basic tools often forces us to discover absolute perfection. And that is the exact same principle that drives modern software coding and digital design."
So that was Mascheroni's pure geometry in 1750,
Let's leap forward again to 1931, arriving in Hungary for our final incredible connection. When billions of people are online at once, streaming HD movies, messaging across continents, searching infinite databases, how does the network sort and organize all that endless data without just crashing into total chaos?
The answer brings us to May 13, 1931, and a brilliant thinker named András Hajnal.
He helped found Combinatorial Set Theory. Now that sounds complicated, but it's brilliantly described as the mathematics of finding structures within infinity. First, you explore combinatorial set theory, then map the relationships between infinite points, and finally discover the equitable coloring of complex graphs. To put that into real-world terms, think of it like meticulously coloring a massive world map so that no two bordering countries share the same color. In our digital world, this translates to routing internet traffic through countless server nodes without overloading them or causing signals to clash. His discoveries are what allow us to safely organize the immense network data we rely on every single second. Hajnal once poetically described his work by saying, "Under the spell of mathematics, we lived on a wonderful mountain of magic." And honestly, that magic, his abstract architecture of infinity, it's the invisible blueprint keeping our digital networks running right now.
So, looking back at our entire timeline, 1750, Mascheroni is born. 1931, Hajnal is born. 1984, Ulam passes away. And 2005, Dantzig passes away. All these extraordinary minds are permanently tethered to this one golden date, May 13.
Every person we met today, from totally different centuries and countries, all asked the exact same fundamental question. What is the pattern hiding inside the chaos? And because they actually dared to look for those patterns, our world today has instant GPS routing, incredible digital graphics, deeply complex simulations, and the internet.
So, as we wrap up this explainer, I'll leave you with this final thought. What invisible pattern is waiting out there for you to discover? Keep asking questions, keep looking at the world with wonder, because hey, the next major breakthrough could very well be yours. Thanks for joining me today, and keep learning.